talk about the first one. So popping into the formula, it isn't too bad. Rho equals the square root of x squared plus y squared plus z squared. It really gets interesting when we start talking about theta. So theta is the arctangent of y over x, so I get arctangent of 1. But again, we have to think about where this coordinate lives. This is saying -1 in the x direction, -1 in the y direction. Second? Oh, I think it's a 2. Quadrant 3. Quadrant 3. Yes. So I'm not going to say it's pi over 4. Say again? 5 pi over 4. 5 pi over 4. Yes. So that's the trickiest thing when it comes to these things. It's not just like plug it in, get some numbers. We really have to think about where these coordinates live. Last one, phi, I get square root 2 over 2, square root 2 over 2. So I land on arctangent of 1 again. But again, I just have to think about this. Now I'm remembering that phi is the distance, the angle from the positive z-axis. So I'm thinking, okay, -1, -1. Now I have a positive z-coordinate. That means I'm going to get an acute angle. So it is going to be pi over 4, as opposed to sweeping all the way around and coming out here to get 5 pi over 4.
So we share the same angle?
Say that one more time?
Can that one, like, can the phi and theta share the same thing? Are they ever going to be the same?
They can be the same. It's just saying you sweep out this way at that angle, sweep down the same angle. Possible.
So is this one pi over 4 or 5 pi over 4?
This one's going to be pi over 4. We don't seem convinced. So don't forget, phi now is a different angle, sweeping down from the positive z-axis. So if I live -1, so in that third quadrant in the xy plane, and I need to sweep down, an acute angle, less than 90 degrees, less than pi over 2. So that puts me at pi over 4. 5 pi over 4 is more
than 90.
So phi will live in that in like the top 2 quadrants basically?
you can have a phi in the bottom 2 quadrants.
How do you know when it's going to live in the top 2 quadrants?
If you have a negative z coordinate, that's going to be when you get something that you had to sweep past
Okay.
to get something in there.
So you can reference your Cartesian coordinates to see what quadrant you're in?
That's exactly what we need to do.
Oh, yeah.
It's not a you can, it's what you need to do. Yeah, so this was a beautiful example here how we had arctangent of 1 twice, but yet we've got 2 different angles.
For basically, for theta, we reference the x and y coordinate, like the position of where it is. And for phi, we think of just the z.
That's a good way to put it.
Okay. 3 over square root 2?
So, yes. So you get 3 over square root of 3. And we don't want square roots in the denominator.
Square root of 3. Yeah.
If you ever have like, this will help you out. You'll see this enough. If you ever get like a over square root of a, then you just get square root of a. How about this? I'll give you another way you could have seen this. That's a to the first divided by a to the 1/2. Subtracting exponents, you just get a. It seems like witchcraft, but
Yeah, you like multiplying it by 1 by the
yeah, once you've seen it
denominator.
the first time, now
Yeah.
you're like, oh, well, it's easy.
Yeah, you're not changing it.
All right, I need to think about where I live, so I'm going back over to my beautiful diagram. I'm actually pretty proud of this. This held up pretty well this lesson. So if I have negative for x and y, negative in the x, negative in the y, and I want arctangent of square root of 3, where on the unit circle is is tangent square root of 3?
Square root. Square root.
So can I actually,
Square.
let me,
Square
this is
root.
what I would recommend doing with your unit circle.
Mhm.
I would just make a note next to each of these coordinates. Just take 2 seconds, do a calculation, do y over the x, and you get 1/2 divided by 2 over square root of 3. You get square root of 3 over 3. And I would just write the tangent value here. I want to write it in the unit circle. Over here, y over x is 1. Just put 1. Oh, you already did this. This is exactly what I would have. So you can go, okay, my tangent values are here. Now with some symmetry, I can just figure out the other ones. So again, x and y are both negative. So in the xy plane, I live in quadrant 3. And what angle in quadrant 3 do I get tangent as square root of 3? 4 pi or 3. So here I've got square root of 3 squared is 3, plus negative 3 squared is 9, so square root of 12. Square root of 12 can be written as square root of 4 times square root of 3. Square root of 4 is 2. 2's cancel out, so I'm left with negative square root of 3. So how does my brain work? If you get arctangent is going to be square root of 3, I know it's going to happen at one of the over 3's on the unit circle. Tangent is negative, so it's in either quadrant 2 or 4. But again, we've learned, or I need to pay attention to the position. Negative, negative, and then now z is negative. So what angle do I want to pick that's past 90 degrees?
opposite one, please?
Over in like the third octant somewhere.
What did we say the options were for tangent?
Right, it's
Pi over 3 or
But I wanted it to be negative, right?
so it's gonna be in the
actually, no, I'm sorry, opposite, which would be 4 pi over 3. Because it's just a negative quadrant. It's like opposite of this.
So I've got the over 3. So I actually don't want it to be the 5 pi over 3 one. Because if I did 5 pi over 3, that's almost a full rotation. So I would be going down and then past. So I actually want the 2 pi over 3.
2, 3, so in the second octant.
We might have want 4 pi over 2 pi over 3. Kind of confused me.
I think going this way is a lot easier. We just got x equals rho sin pi cosine theta.
Kind of running on time or something, and just leave it like that. Is that full credit or do you want to simplify?
It would be a lot of points, but if it's multiple choice, maybe do one of them, rule out some ones that can't be. So this is a good, interesting point. We got negative 10, 0, 0. Let's make sure that we did that right. We got a line of zeros. So this is saying go out a distance of 10 from the positive x-axis, sweep to an angle of pi, so that points in the negative x direction. And now my phi is pi over 2, so from the positive z-axis, sweep down, so I am living in the xy plane. So I'm traveling along the negative x-axis, because I swept down at pi over 2 for my phi, and I wrapped all the way around here. So, yes, you're just going in the negative x direction, and that's it. So you get negative 10, 0, 0. 3 over 2. Second?
3 cosine?
I have no idea.
I think it's just the
It's just one of those.
all good.
Yeah, making sure this answer makes sense. What I'm thinking about is, I got the same coordinate twice. I got 3 square root 6 over 4 for both of them. So if I'm going a distance of 3 square root 6 over 4 in the x, and a distance of 3 square root 6 over 4 in the y direction, I kind of live along this central line here. Well, hang on, if I live right between the x and y axes, then I must have swept out an angle of pi over 4. And I did. So it looks pretty good. We'll spend some more time with this next class. I don't want to rush through that in the practical problems.
Good.
So we will spend a little more time talking about spherical coordinates when we come back on Monday. If you guys are interested in taking the retake, we will probably move downstairs to the student lounge. I think one of the questions was having the ability to ask questions before taking it, which I'm totally fine with. If you want to just take it so you can go home, that works too.